Okay, so you guys played for, I don't know, 10, 15 minutes?
Mm-hmm.
And so what are some things that you found out?
Well, we found that linear likes, so I'm
This
not
one
sure.
here.
Yeah, you can't really see them from the camera, but
So it likes the pattern where there's these big
two
groupings
clumps.
All right.
because it can separate them really easily.
Okay.
And then the tangent, or the hyperbolic tangent one, likes,
Um,
Well, what happens when you do hyperbolic tangent on this one?
well, it works.
it works about the same kind of curvy line.
What do you notice that's different?
It's a
Well,
curvy
the
line.
line, it's not a line. It's more of like a wiggly
Okay.
thing.
Yeah, that's interesting. Okay.
So it can do, the hyperbolic tangent can do this one pretty easily.
Uh-huh.
And the linear one can't because it's not in lines.
All right, so this was hyperbolic tangent trying to solve this problem?
Yep.
Yeah.
Okay.
And then the linear one,
Here's the linear one trying to solve it.
it can't do it because it's not. It can't really separate into lines.
Interesting. Okay.
And then this one,
Mm,
the linear is just linear trying to do it.
All right, what do you think the problem here is?
Well, that on the lines there's blue and orange on every line.
Okay.
And our hyperbolic tangent can do this one.
Relatively easily.
So that's in
I mean,
this
it
one.
takes a bit of time to figure it out, but it gets it.
It's funny. It says that in the middle will be blue.
So it gets this.
Why do you think it says that? So remember, hyperbolic tangent is sort of like saying either you've got it right or you've got it wrong.
Yeah.
Well, I mean, it's got to choose one to be.
Well, but you can see that there is a kind of a white border where you know it sort of doesn't quite know, or at least there is a border. But so why do you think it got blue in the middle?
Well, because maybe the blue was closer. The blue squares were closer together than the orange squares, kind of, and then they just put blue.
What do you mean closer together?
Closer to the center.
Oh, so you think some blue ones were closer to the center?
I think that it could be randomness and that orange could just as easily be in the center as well.
Oh,
Or
interesting.
we could try it again and just try to see it.
See it again. Reset.
Maybe it's put orange in the center.
Yeah, it's an interesting question. Does it solve it the same way every time?
Well,
No, it doesn't.
This does not look the same.
it's kind of
Did you change anything? Did you add noise or anything?
I don't know.
It's a different.
different setup. Well,
different
but this
solution.
time there's just white in the middle, but it's not really in the squares anymore.
Okay, but it still seemed to do a pretty good job solving it. What is the loss now?
Test loss is 0.025.
Okay, so here's a different solution. Nice. Okay.
Just to see it again, I guess.
Maybe it'll get it right. And yeah, it kind of
It
got
solves
it.
it a little faster this time.
So maybe it knows what to do.
Well, and this is telling you that there's many different ways to solve this problem, or that the computer comes to a solution on this.
Yeah.
It's an interesting problem because you're sort of used to saying, especially for the problems you guys normally see in math, you're used to saying like, here is the solution.
Yeah, this is just one of many solutions.
Yeah, there's lots of different solutions to this problem. Okay, so let's go back to the linear versus hyperbolic tangent. Was there another one that linear did well on, or didn't do well on?
No,
Well, no one really did well on this one.
Yeah, the spiral is tricky.
But the linear only did really well on this one.
The linear did well on that one. Okay, and what happens when you do linear on this one?
This is the one we saw, and it just makes a line like that.
Okay, and so what makes you think linear does well on this?
Well,
because it gets 0 wrong.
there's no lines that you can slice that are horizontal lines that you can slice that contain both orange points and blue points.
Okay, interesting.
So now, what happens if we add noise to this? So does linear still do well?
It doesn't really like noise because
That's what happens when you add noise.
Okay, so there's a lot of noise here. Now before you press play on this, what do you think linear is going to do on this?
It's probably going to say, like, I did this before and I slice a line down
Well, it doesn't remember all the way back to the one it did before. So once you restart this, the learning goes to 0. So it doesn't have a memory.
So I think it's going to just try to find that line, but then it's going to say, oh no, there's like a mixture of blue dots and orange dots.
Okay, so what do you think its solution is going to look like?
Put that area kind of faint,
Uh-huh.
and then then put orange and blue areas.
All right, so what do you think the solution's going to look like?
Like the most orangey orange is going to be here,
Uh-huh.
and it's going to get fainter as you go to the center, and it's going to be white here, and then it's going to get blue, and the bluest blue is here.
Okay, well, let's see what happens.
Okay. So yeah, it kind of tries to create that line, but
It kind of gets it, and it looks sort of the same as the one with no noise, but...
Now, do you think that's a good classification of these, of separating by that line?
It's an okay classification.
Okay, now let's go back to hyperbolic tangent. Now, what do you think is going to happen with hyperbolic tangent here?
Well, there might be like two blobs, like kind of one going around here and one going here.
and then maybe kind of curls out to here in the corners.
Okay, do you think hyperbolic tangent or linear is a better way to approach this particular problem?
I'd say linear, since there's more like big clusters.
Okay, what do you think?
Yeah, because let's say linear.
Okay, all right, let's see.
So I think linear had a test loss of 0.124.
Okay.
Let's see. Well, already it's at 1.
Well, it did almost exactly the same thing, but the line's a bit curvier.
And the test loss is going up. So linear is just a
Oh,
little
look at it now.
It's just a little better.
Still evolving.
Linear seems to have done better, but not that much better.
Still going though.
Yeah, it's a very different shape.
Curvin 38.
Well, that's cool. That's cool. See, the interesting thing is this one we actually knew was a linear one, and we just added some noise to it. And the linear one, forces it, I guess, to be linear. The hyperbolic tangent one is making a much more complicated sort of cut in the space here.
Mm-hmm.
All right, well, this is cool. This is very, very fun to play around with. I'm glad you guys wanted to do more of this today. Good job.